My name's Jim Calder and I'm a director of Calder Mahoney Proprietary Limited. We're a Brisbane-based Australian engineer who operate globally, and we have some expertise in copper solvent extraction plants, flotation, solvent extraction and heap leaching, gravity concentration work, carbon and leach, gold work and zinc processing. I guess the way I personally became involved in copper solvent extraction plants was the S&K copper project in Myanmar that was built by Ivanhoe, a Canadian company. Their joint venture group with the Myanmarese government was S&K Copper. In 1997, I was the project manager for designing and later on constructing the S&K Copper in Myanmar. It was a 25,000 tonne per annum output plant, highly successful project. It produced 15% above its nameplate capacity in the first 12 months, and we got it up to 100% capacity in 6 weeks after turning the rectifier on. So as far as heap leach copper solvent extraction plants go, that's got to be just about the best performance you can get. Following that job, I did many studies, mainly for Straits Resources, Wind Creek, an expansion of the Nifty plant in Western Australia. So we started working for clients, small clients in the beginning, doing whatever we could. Started off with gold plants and bauxite beneficiation plants, things like that. Anyway, one day we got an inquiry from a client who wanted a small demonstration plant, a copper solvent extraction demonstration plant in Indonesia. And he approached me because of my experience of working in China. And he asked me who he would go to in China to buy a 5 tonne per day demonstration plant. And I thought about it and said, well, there's really no one. I mean, if you want a 5 tonne per day plant, you're better off just designing it and building it yourself. How would I go about that? I said, well, give us a design contract, we'll design it and you can build it. A couple of weeks later, a bit of discussion, a few sample drawings, etc. We had the contract to design the Wetar demo plant. And in February of 2008, that plant was commissioned. Its nameplate was 5 tonne a day, but it was probably capable of producing 6.5 tonne a day. Its purpose was to prove the process on that ore body, that the leaching worked. Its second point was to train operators and de-risk the project, because the ultimate goal was to build a 25,000 tonne per annum plant on Wetar Island. And that's a pretty big step for a junior explorer to go to. We were pretty small in those days. We had less than 10 people. The client was looking for minimising the costs, so they bought a lot of the equipment in Indonesia. Most of the work was done in Indonesia. We designed everything, the process, the civil, structural, mechanical, and the electricals, and all of the electricals were built from our drawings in Indonesia. We placed orders very, very quickly for all of the key components. The costs for the stainless steel settler tanks were a lot lower than I would have expected, whilst there were a lot of questions from the fabricator during the fabrication because the tanks are relatively complex. There were 3 settler tanks and they were fabricated in a single piece and transported to site. There were some quite interesting challenges. There's very little flat land anywhere on the island. We had a footprint that was very, very small, and once you get past that footprint, the land just fell away completely. A lot of the opposition firms that will offer an SXEW plant basically have pre-engineered designs, a particular size of settler. They might have molds for making them in fiberglass, or they've got a set of drawings that they've produced before. When a client comes in and asks for a particular size of plant, they don't necessarily go and change the drawings. I've seen plants that are supposed to be 3,000 tonne capacity, and they just have a set of drawings for a 5,000, and that gets sold off to them as a 3,000 tonne plant, and they end up paying more. It costs more to run, and if it's too expensive, the project might not go ahead at all. We're basically engineers. We can tailor make a plant to suit a client's ore body requirements. We're not manufacturers of equipment, so we don't try to push any particular brand or any particular technology per se. I guess our philosophy is to look at the ore body, look at what the project can carry, what's economic, and design basically from scratch, so we can change our designs very quickly and tailor make all of the tankage, etc., to be the exact size it needs to be for that production case. We actually do rework the drawings to fit the client's specific case, so that when we're talking about a specific size, whether it be 3,000, 6,000, 10,000, 15,000, 25,000 tonnes of copper cathode, we will design the plant specifically for that capacity. It's like buying a suit. We say, well, what fabric do you want? What style of suit do you want? And we measure the body and we make a suit for that particular client. So what we do is we look at the ore body first of all and see how it's going to leach, what reagent consumption, what the acid consumption is, whether the project's economic or not, and then look at the predicted life of the project, try to come up with a production rate, and then design the plant for that production rate. Projects don't need to be complex. You can get to the stage where the client really just has to own a mining lease. Oh, that's why you're an engineer.